Very good morning to all of you.
Yes, good morning, Father. Good morning, good morning.
Good morning, sir.
Yes, good morning.
Sir, the voice cannot audible.
Yes, yes.
Good morning, good morning. Renuka Devi ma'am, good morning, welcome. Renuka Devi ma'am, welcome.
Good morning, sir.
Yes, good morning, very good morning.
The same program we are also streaming in YouTube live. So students, those are not able to join, and the participants, those who are not able to join, they can through YouTube.
Hi everyone, let us start our program. Greetings to all of you. This is Sister Rosaline from St.Joseph University, Nagaland, Dimapur. A conference is a gathering of people with a common interest or background with the purpose of allowing them to meet one another and to learn about and discuss issues, ideas, and work that focus on a topic of mutual concern. On behalf of the management and on behalf of Department of Physics, I extend a warm welcome to all of you present. Now, we will move on the program. First of all, I would like to thank each one of you for joining this two-day National E-Conference on Current Trends in Nanomaterials NECCTN Conference 2021. I feel great proud to say that this conference has been organized by our St. Joseph University, Nagaland, Dimapur. Our St. Joseph University organizes very many conferences like this, researchers, scholars, scientists, and etc. at all levels to enlighten the young minds and promote the participation of students at all levels. I bid a very warm welcome to all the renowned speakers and delegates who took their valuable time and join us today to be a part of this conference. We are honored to have you all with us today. Now, we start our conference with a prayer. Pray in the Spirit at all times and every occasion. Stay alert and be persistent in your prayers for all believers everywhere. Ephesians chapter 6 verse 18. Yes, let us welcome the Spirit of the God before start our gathering and let us seek His blessings on the endeavors. Now, I invite Father L. Savariappan, the PRO of St. Joseph University, Dimapur, Nagaland, to lead us in prayer.
In the name of the Father, the Son, and the Holy Spirit. Amen. In Him we live, move, and are we. God, Father, we thank you for this new day. We come to you this hour asking for a blessing and help us. We are gathered together for the National E-Conference on Current Nanomaterials organized by the Department of Physics, St. Joseph University. We pray for guidance in the matters at hand and ask that you bless us. We thank you that you promise to be with us always. Thank you that your presence is with us right now. Today we give our hearts, our minds, and our lives. Come speak your words of life into our beings. We pray that you would deepen our comprehension, broaden our thinking, and transform our understanding of what we are able to learn through this national conference. For you are our wise counselor, our perfect teacher, and our faithful friend. Lord, bless us, with us, and lead us. We make this prayer through Lord Jesus Christ, your Son, who lives and reigns in the Holy Spirit, one God, forever and ever. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Thank you, Father, for your prayer and support for this event. Welcoming is an art and it sprouts from the heart. It is a pleasure to extend a cheerful welcome to everyone gathered. Now, I would like to invite second M.Sc Sultan to propose the welcome address. Welcome, Sultan.
Good morning, everyone. This is Sultan Jud, M.Sc second year. Warm greetings to everyone present here. It is indeed a great pleasure to admit this august gathering. On behalf of St. Joseph University, Nagaland, I proudly welcome you all for 2 days National E-Conference on Current Trends in Nanomaterials, NECCTN 2021, organized by Department of Physics, St. Joseph University, Nagaland. I warmly and fully welcome a man with a great vision and mission, an icon for hard work. He is our chief patron, Reverend Father Dr. J.E. Arul Raj, the Chancellor and founder of the MI and MMI. He is the pillar of our prestigious university, the man who dreamed to educate youth of the nation, who crossed the boundaries of excellence with his great spirit towards his profession. I welcome you, sir. I also welcome our patron, who is none other than Dr. D. Ganadurai, Vice-Chancellor of St.Joseph University. He is an icon for dedication, who have been the pillar behind this event. The most dedicated personality of our university, who sleeplessly work day and night for our university. I welcome you, sir. I proudly and warmly welcome our Dr. Anthonyson, Registrar of St. Joseph University. He is the model of hard work. I welcome you, sir. I gladly welcome our sister M. Hines, Deputy Registrar, St. Joseph University. She is an icon of dedication. I welcome you, sister. I warmly welcome the man who takes care of our exams. He is none other than Dr. Tyagarajan, Controller of Examination of St. Joseph University. He a hardworking personality of our university. I welcome you, sir. I will also like to welcome Father Francis Xavier, Deputy Controller of Examination of St. Joseph University, of hard work and dedication. I welcome you, sir. I warmly welcome Sister I. Arokia Mary, Dean of Administration, the personally who work day and night to maintain the administration of our university. I welcome you, sister. I proudly welcome Professor Charles Ezen, Dean of Student at St. Joseph University. He is the personality who dedicated all his precious time for the student. I welcome you, sir. I happily welcome our father, L. Savaripan Pro PRO of St. Joseph University, an icon of dedication and hard work. I welcome you. I feel happy to welcome Chairperson, H.O.D. of Physics Department, St. Joseph University, Professor Dr. C. Kadurai, who have been the backbone of this conference, an icon of dedication towards his profession. I welcome you, sir. I heartily welcome the convener of this conference, who is none other than Dr. R. Amagal, Assistant Professor of Physics, the man who worked day and night for this conference. I welcome you, sir. I also like to welcome the organizing committee members who have put their full efforts for this program. They are none other than our assistant professors, Dr. A. Arun Kumar, Dr. P. Sudarajan, Dr. M. Shanmugam. They are the gems of physics department. I welcome you. I gladly welcome chairpersons of this conference, Dr. L. Val, Assistant Professor of Department of Physics, Government College, C. Maltur, Chandapur, and Dr. E. Izal, R. Izal Pavi, Associate Professor of Department of Physics, Thiruvalluvar, Government Arts College, Viruttachalam. They are the dedicated personalities towards their profession. I welcome both of you, sir. I would also like to welcome our invited speaker, Dr. Annamalai University and Professor of Assistant Professor of Physics, Indian Degree College, Autonomous, Bangalore. I welcome both of you for your previous time. extend my welcome to all the
Thank you, Sultan, for welcoming the gathering. Now it is time to call upon Dr. D. Gnanathurai, Vice-Chancellor, St.Joseph University, Dimapur, Nagaland, to release conference proceedings and address the gathering. Welcome, sir. The floor is yours.
Good morning.
Good morning, sir.
The dignitaries
Good
who
morning,
are
sir.
participating in this e-conference, the guest speakers, session chair, faculty members, and the participants. A very good morning to all. So I am really happy to deliver my inaugural address of this e-conference. First of all, I would like to convey my best wishes on behalf of our Chancellor and founder of DMI and MMI, and on my own behalf. So this conference, the theme, I understand it is the nanomaterials. So I am very much delighted to witness the inauguration of this conference. I would like to convey two things. One is regarding the conference theme, and the another one, the educational experts, how to react or how to respond with this pandemic situation. So the first thing, this nanomaterial, the theme is very attractive, and it is one of the emerging fields. So all of you know about the nanomaterials. Because of its abnormal or different electrical and other characteristics, the usage of nanomaterial is enormous. I would like to pinpoint one or two important uses. That is, it is being used in automobile tires to fill up the small gaps so that the braking system is improved enormously, and also the anti-glare glasses. Then it is also being used as a coating of the solar cells, which will improve the transparency so that the maximum solar particle will be, chemical will be exposed to the sunlight. But in addition to all these applications, it is having one important application, that is in the field of medical. Medical field, it is having enormous importance. One thing is identifying the defective cells. That is, it is being used in medical imaging. For example, if you do the MRI or whatever the scan by normal process, then the defective cells could not be identified. Instead of that, if these nano chemicals or nanomaterials has been injected into the body of the human being, then afterwards this type of scanning has been taken, then This nanomaterial, because of its fluorescent nature, it will show or it will improve the contrast of the cell, that we are calling it as a medical imaging. So I request all the researchers, those who are doing the research in the nanomaterials, in addition to all the advantage, you concentrate on medical imaging system. The reason is identification of defective cells, identification of dead cells is enormously improved due to the injection of nanomaterials. Even today, as you all know, due to the pandemic situation of coronavirus, many suffered, the entire world suffered. The main reason initially why we had a high death rate is the virus cell cannot be identified. We don't know in future, many such type of things may or may not happen. But due to our technology, we can overcome all these things. The important thing is before finding the remedy or before finding the vaccine, the first initial stage is we have to identify the existence of that virus in human body. So this type of medical imaging with the help of nanomaterials will help lots to identify such type of very small viruses or foreign particles in our body. So in this conference, I think it is a right forum also. I would like to appeal all the researchers, you expand the scope of research towards the medical imaging with the help of, by exploiting the properties of the nanomaterials. The next thing, I'm really happy to have this e-conference because nowadays you find, I think you have sensed so many things due to this pandemic situation. Many of the activities have been stopped and many of the activities have not been done due to the absence of physical presence. For example, a factory is not running to avoid the crowd. Shops are closed or partially opened. So many mishappenings are there due to this situation. But I don't know whether you identify or not, the education system is going on in a proper way by using some other means. This is because of the effort of all the learned people. Though all the activities have been stopped or have been delayed for this type of pandemic situation, the education is going on in a proper way. Maybe 10% loss may be there, but without any academic loss, the teaching learning process is going on. Only thing is we are using some alternate ways. What is the reason for this is the entire education field is governed by the learned professors who are capable of always accommodate the different things, who are capable of always doing or finding the alternate ways for delivering their or for executing the teaching learning process. This is the blessing of the educational system. This is happening because of the existence of the educational experts, the learned professors in the field. Always, whatever mishappening are there, always the educational experts have proved themselves without having any loss in the teaching learning process. This e-conference is a good example for that. So my dear learned professors and researchers, whatever may be the situation, you continue your research. you deliver your lecture in different means. You keep the teaching learning process always live so that the students community will be the beneficial one. Because if they lose their education at this level, then definitely it will affect the future career. So we have to give a guarantee to them. Because of this, in spite of this situation, you will be having a good education. That type of guarantee should be given by a learned professor, whatever the mean of way we are choosing to deliver our lectures. So this is the National E-Conference is one of the good examples for that one. So as I outset, before concluding my inaugural address, I would like to congratulate and appreciate the department, faculty members in general, the HOD in particular, for organizing such type of national e-conference. And also, I would like to thank all the participants who has chosen this e-conference to deliver their findings or their research findings. I come to know that though we have arranged this conference within a short time, we had a good response from the public. We had a good number of papers for this presentation. My dear researchers, I would like to convey one message to you all. Research is the endless process. Research doesn't mean that getting a PhD degree or getting a PD of fellowship. It is a continuous process until our life period. I don't know that is the background of the participants or the people, those who are going to deliver their research finding. You may be a PhD holder or you may be doing the PhD degree. So whatever it may be, don't stop your research, because research is not for getting a purpose of research is not getting a degree. The purpose of research is helping the society, improving the society, facilitating the society, or make the human life a sophisticated one. You just go back 100 years, how the human beings led their life, how they are leading a sophisticated life. These all things are because of the research finding, starting from our cell phone to computer or advancement in the medical treatment, whatever it may be. It is all the things are based on the findings of the research which have been carried out by the research scholars or the scientists like you. So it is my humble request and appeal to all the participants or the researchers, don't stop your research process. Though you have received a PhD degree, though you have become a PDF postdoctoral fellowship, though you have got so many that is awards and all the things, you keep on doing your research, which will definitely will lead to get many deliverables, which will be very much useful for the human being, which is very much useful for the society, which will uplift the life of the human being. So with this one, I again thank all the participants for your paper and your participation. And again, I convey my best wishes to all the faculty members of the department and also the students of the department who are very active in organizing all such e-conference. So with this, I would like to wish this e-conference a grand success. Thank you.
Thank you very much, sir, for your thought-provoking message regarding this topic. Thank you, sir. This is our pleasure to invite Dr. A. Anthony Dawson, Registrar, St.Joseph University, Dimapur, Nagaland, to give keynote address for this conference. Welcome, sir.
Thank you, sister. Honorable Vice-Chancellor, esteemed Chief Guest, Honorable Dr.K.Murgan, Registrar, Bharathiar University, and former Vice-Chancellor of Thiruvalluvar University, respected Controller of Examinations, dear Reverend Fathers and Reverend Sisters, respected Deans, respected HODs, respected session chairs and participants, and my dear students. Very good morning. I deem it a great honor to deliver this keynote address at this national conference on current trends in nanomaterials. I appreciate the HOD of Physics, coordinator, faculties and students for choosing the topic nanomaterials. This itself is a current emerging technology actually. As our VCSR said, it's going to evolve, it's going to benefit the society to a great extent. We all know about the transistors, though it's very tiny device. It was invented in 1940s by 3 individuals. Even they might have not expected that the small device will make such a great revolution in the field of electronics and computers. It paved the way for the generations of computers. Initially, we had vacuum tubes for computers, maybe sizing the big building or big room, something like. After the invention of the transistors, the size drastically reduced. We had a small scale of integration, then VLSI, very large scale of integration. Then we are in the right now of 5th generation intelligent based computers. These are all based on, because of these small invention transistors. Similarly, in the current era, the mobile phone, as VCSR quoted, it was invented in the 1970s only actually. But it becomes a destructive technology to just move away many aspects in the business. For example, telegram, postal department, studios, even STD booths. Okay, such a destructive technology. But it is a predominant device, become the inevitable part of every human being. Such a way it provides the benefit to the society. So like this, no, the beginning of any invention may be quite simple or quite humble, but in what way is going to support many other disciplines, that is very, very important. So that's why I would request the researchers, faculty and students, please do research. No need to worry where you are. You may be in the humble level, you may be in the beginning level, no need to worry. Okay, you put your best effort, you start doing. Because there is a direct proportionate between the research and development and teaching and learning process. The more you do research, there will be a progress in the quality teaching. So that is very, very important. So start doing research. And also, I would suggest always align your research objectives with the societal and national requirements. As our Honorable Vice-Chancellor quoted, okay, it is important. I would like to share the experience explained by our former President, Dr. APJ Abdul Kalam. I had seen those children struggling with the artificial limbs that weighs at least 4 to 5 kgs. My team made one with the composite heat materials used for rockets. This one is 10 times lighter. He cherished it more than launching hundreds of rockets. and said it was bliss to see children's smile. After wearing the lightweight prosthesis on their legs, designed by him and his team. So that is the research, that is the outcome of research, that is the leadership, that is the responsibility of the researchers actually. So hence, my dear students, once again, I just suggest you, urge you to do more research. Okay, faculty members, guide students to do research and publish more papers, and always align with the societal and national requirements, so that we all can contribute towards the great nation. So once again, I wish you all success. Thank you so much.
Thank you very much, sir, for wonderful message, and you have boosted us to do the researches. Thank you very much, sir.
Thank you, sister.
Now, the proceedings of the conference starts. I am honored to invite to be the guest speaker, Dr. N. Shanmugam, Assistant Professor, Department of Physics, Annamalai University. He has 12 years teaching experiences, 15 years of research experiences, guided 5 PhD scholars and completed, and 1 is ongoing. And M.Phil 15 scholars guided, and he has published 50 national and international articles. And the citation is 1664. Sir, we know that you are a terrific speaker, and delegates will gain much from your talk on this topic of photocatalysis of semiconductor nanoparticles. Now, I invite Dr. N. Shanmugam to take over this session.
Thank you.
Welcome, sir.
Thank you. Just a minute. There is a technical problem. இது ஷேர் ஆக மாட்டேன். இதுதான் நம்ம பவர் பாயிண்ட். இதை மினிமைஸ் பண்ணுறேன். இதில் கூகுள் மீட் ஷேர் திஸ். ஷேர் பண்ணுங்க. பிரசன்னா தானே விண்டோ. First of all, I wish to thank my position to the authorities of St.Joseph University, Nagaland. They have given this opportunity to meet all the learners as well as the experts in the field of nanoscience and technology. I would like to make this session as a discussion, not an argument. if it is a discussion, at the end, you may come to the conclusion which one is correct. If it is an argument, we may conclude the session like who is correct. Then we know that the entire universe is made up of 5 elements: water, air, fire, air, and space. Water is major factor for all. The earth contains water. The earth is made of fire. Then origin of fire is air. And the origin of air is space. So the space is the base for everything. Our Lord Nataraja specifies the symbol of space to make everything as positive. So from the place Chidambaram, in which I am opening my presentation regarding the photo catalysis of semiconductor nanoparticles. In each and every day, people are talking about nanoparticle. As you know that particle of any shape with a dimension ranging from 1 to 100 nanometer can be termed as a nanoparticle. The nano is derived from the Greek word nanos, meaning dwarf or very small. The nanometer is expressed in terms of 10 power minus 9 meter. This is familiar to all. I would like to place a question for all the guys regarding the comparison of size of an atom with a nanoparticle. Most of the researchers are thinking like so. The size of the nano is lesser than that of an atom. But as we know that the atom is having the dimension of 10 power minus 10 meter. But the dimension of nano is 10 power minus 9 meter, which is equal to 0.1 nanometer. If you consider a particle of size 1 nanometer, that is not smaller than atom, that is always bigger than an atom. Because the atomic dimension is expressed in terms of 0.1 nanometer, which cannot be achievable. But if you place a question in general to the research community, which one is greater in size, either a nanoparticle or an atom, simply they may point out atom is greater in size. You should make the comparison in this way. Our theoretical understanding should be presented in this way alone. Atomic dimension, we are calling the nanoscale as atomic dimension, but if you prepare a particle of 0.1 nanometer, that is equivalent to size of an atom. So the size of the atom is lesser than that of size of the nano. In this way, we have designed the scale. This point should be clarified among the research community. If you want to teach the paper nanoscience to the younger generation, you should make the clarification in this way. People may think like so, nano is the smallest size. The size of the atom is bigger than the nano, but it's not correct. If you approach the size of 0.1 nanometer, that is equivalent to size of an atom. So atomic size is lesser than that of nano. Now, on the basis of number of molecules, we can classify molecules, nanoparticles, and bulk material. If the number of atoms are 2 to 10, starting from 2 to 10, they are called molecules. If the number is exceeding, that means ranging between 100 to 10 power 6 million, then they are coming under nanoparticles. If the number of atoms are more than that of 10 power 6, that material is called as bulk. This classification is made on the basis of number of atoms. This is called simple scaling. As we know that the nanoparticles are having special features when we compare the nanoparticles with its counterpart, bigger size, that is large scale particle, the bulk material. The nanomaterials are gaining superior property because of its high surface area to volume ratio. You should understand this concept clearly, then only we may realize the importance of nano. what is meant by surface area here? The way in which we can get high surface area to volume ratio if you change a macroparticle or bulk material into nano. See this first sphere. Share agaliya? Oh, share agala. Hello. Hello.
Sir, we are hearing you.
Share whether the things are sharing or not.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay. If you think about the surface to volume ratio, it is a major task in the case of nanoscience. Consider a sphere with the radius 1 centimeter and then find out the surface area of the sphere using the formula 4 pi r square. We can get the surface area of 12.6 centimeter square. Using the formula 4 by 3 pi r cube, find out the volume of the sphere. Then the volume is 4.2 centimeter cube. Using the formula 4 by 3 pi r cube, if we calculate the volume, we can get the volume of the order of 4.2 centimeter cube. Then convert the sphere into 8 parts, with each is having the radius of 0.5 centimeter. Now find out the surface area of all the 8 particles. That means if you want to calculate surface area of the single sphere, you have to use the formula 4 pi r square. Here r is 0.5 centimeter. And then find out the total surface area of all the 8 particles. That is 25.12 centimeter square. But if we calculate the volume using the formula 4 by 3 pi r cube, we can get the same volume 4.2 centimeter cube. There is no change in the volume. In the case of first sphere, the volume occupied by the first sphere is 4.2 centimeter cube. Then the sphere is bifurcated into 8 particles. Then the volume occupied by all the 8 particles is also 4.2 centimeter cube. But if you think about the surface area contributed by the first sphere is 12.6 centimeter square, whereas the surface area occupied by all the 8 particles is 25.12 centimeter square. Almost the surface area is increased to twofold, even though the volume remains constant, whose value is 4.2 centimeter cube. Now, if you want to calculate surface to volume ratio, that means surface divided by volume, it is increased for the second case. That means if you convert a single particle into 8 particles, the surface to volume ratio is increased. So that if you convert a bulk particle into nano, compulsorily the surface area increases. Then what should be the benefit of increasing the surface area? We have to see. As the number of atoms at the surface increases, the surface forces becomes more dominant. More and more atoms are available on the surface. More surface atoms are taking part in a reaction. Suppose all the atoms are present in the interior, the reaction is not fast. If more number of atoms are present at the surface, the reactivity should be enhanced. So that only on the basis of increased surface area, when you convert a material from bulk to nano, the following things are to be enhanced. That is mechanical property of a material, electrical property, chemical property, phase transition, nature or temperature, magnetic and optical properties are changed. If I make a bulk material into nano, these properties are tailored because of enhanced surface to volume ratio. Say that if you think about mechanical property, consider a pencil. The pencil lead is made up of graphite and clay. If you make a press, it will brittle. But if you convert that graphite material in the nanoscale, its strength can be enhanced, which has higher strength, that is stronger than that of steel, as well as it is 6 times lighter than a steel. If you consider graphite as a bulk material, which is nothing but a pencil lead. The pencil lead is made up of graphite and clay. Then convert this graphite into nanoscale. Its ability, that means stress storing ability, is enhanced. It is acted as a steel. Its strength is more than that of a steel, but it is lighter than steel. That's a peculiar property of nano. Then copper is known to you. If you consider a copper in the nano form, which is highly elastic at room temperature, we can stretch a copper from 1 centimeter to 50 centimeter if it is converted into nanoscale. If you take a bulk copper, if you consider the length of the copper is 1 centimeter, you can extend the 1 centimeter copper to 50 centimeter if it is in the nano form. So such elastic property it gains. Then if you think about the electrical property, silver is the good conductor of electricity, but we won't use silver in our household article because of high cost. If you convert silver from bulk to nano, its electrical property is highly enhanced. At the same time, if you think about the insulators, the insulator in bulk is converted into nano form. Its current blocking effect is highly reduced because of quantum tunneling. Then the tunneling current increases exponentially as the thickness of the insulator is decreased. As you know, the process of tunneling, quantum tunneling, if the energy of the particle is lesser than the height of the barrier, there is no need for the particle to come back. There is another one probability for the particle to make its forward journey without reflection by the way of barrier penetration called tunneling. So with the help of quantum tunneling, the current is passing through the insulator so that the insulator is losing its property if it is changed from bulk to nano. Then if you think about the chemical properties, nanoparticles can make materials most chemically reactive. To understand this, take the simple example. Take the container or a glass which is filled with a cup of water. Place a tablet gently on the glass containing water. To dissolve that tablet, the system takes more time. Suppose the same tablet is made into powder and pour it on the glass containing water, it is started to dissolve immediately. This points out that if you reduce the size, then the reacting ability, chemical reactivity is highly enhanced. Then we should talk about the phase transformation. Nanoparticles have a lower melting point than their bulk counterparts. If you think about a material in bulk form, it has some melting point, and reduce the size into nano, then the melting point decreases drastically. First of all, we should know the meaning of the word melting point. Most of the researchers are not having the ability to define the term melting point and boiling point exactly. If ice is taken for our consideration, which is made at a low temperature of minus 18 degrees Celsius, then if you apply heat energy, the applied heat energy can be used to increase the temperature of ice. Suppose ice is reaching 0 degrees Celsius, even though if you are applying heat energy continuously, the applied heat energy may not be used to increase the temperature of ice, but can be used to change the state of ice, phase transformation. That is, ice is started to melt. The solid is changed into liquid. The solid form of ice is changed into water. That is liquid. The temperature at which the phase transformation is taking place, that is, a solid is converted into liquid, is called melting point. In the same way, we can explain the boiling point. Once the ice is started to melt, if you apply heat energy continuously, the applied heat energy can be used to increase the temperature of the system up to 100 degrees Celsius. Once 100 degrees is reached, even though if you apply heat energy, the applied heat energy may not be used to increase the temperature of water, but can be used to change the state from liquid to gas, which is called as boiling point. So it is taken as a latent heat. In this way, we should realize the point. If you convert a particle from bulk to nano, its melting point decreases. Then magnetic property. In nanostructure, randomly orientation of magnetic spin inside the particle is mostly observed. As a result of this, you can get zero remnant magnetic field. That is, residual magnetic field is zero and coercivity is also zero. If you apply magnetic field, the substance is magnetized once it is reaching the saturation. That is called as saturation magnetic field. If you withdraw the magnetic field applied, then demagnetization is taken place, even though that material may have some amount of magnetic field with it, which is called as remnant magnetic field. Then the opposite force you have to apply to bring back the system to zero magnetic field is called coercivity. If you apply, if you convert a substance from bulk to nano, the nature of that material is holding super paramagnetic. That means zero residual magnetic field as well as zero coercivity. In this way, the magnetic property is changed if you convert a bulk particle into nano. Then if you come to the optical properties, if I say optical property, which talks about the interaction of light with particle, that means interaction of electromagnetic radiation with matter is the optical property. If you place a particle and the light is allowed to fall on that particle, the way in which the light is interacted with the particle will provide the information about the optical property. Compared to bulk, optical properties of materials in nano dimension are highly improved. You see that gold in bulk form is orange yellow in color and is changed into brownish block on reducing the size. If you reduce the size, you can get different colors, so that the nanomaterial is having enhanced optical properties. There are two factors that are dominating to justify the optical properties in the nanoscale. One is surface plasmon resonance. This is made for metals, metal nanoparticles. And another one is quantum confinement effect. We can observe the same in semiconductor nanoparticles. The size dependence on the optical properties of nanoparticles is a result of these two. The surface plasmon resonance is especially connected with the metal nanoparticles like silver and gold. Then quantum confinement effect is expected in semiconductor nanoparticles. First, we should talk about the surface plasmon resonance. As you know that atom consists of the positively charged sphere called a nucleus, and electrons are orbiting around the nucleus in the privileged orbit. Then if you think about the charge of the nucleus, which is positive, which contains positively charged proton and electrically neutral neutrons. Electrons cannot exist inside the nucleus. You should arise a question here, why electrons cannot exist inside the nucleus, even though the protons and neutrons are existing. The necessary condition is for a particle to present inside the nucleus, it should possess the energy of the order of 10 million electron volt. But electrons are having energy of the order of only 2 to 5 million electron volts, so they cannot exist. If you increase the energy of the electrons using particle accelerators, say betatron, electrons can also exist inside the nucleus. If electrons are allowed to present inside the nucleus, the stability of the system is disturbed and the separation is taken place. So that the electrons are orbiting around the nucleus in the privileged orbit. They are continuously vibrating. If light is allowed to pass through the material, the electromagnetic radiation is also vibrating, which has both electric and magnetic field compartments. Then the vibration of the electron is exactly matched with the vibration of the incident light. The condition of resonance is achieved, which is called as surface plasmon resonance. It is possible in metals, not in the case of semiconductors. But in the nanoscale, the properties changed entirely. If you think about the semiconductor nanoparticles in bulk form, the valence band and the conduction band are separated by a forbidden gap of certain width. The width is very small in the bulk material. If you convert that bulk material into nano form, the extension of bandwidth is observed. Apart from that, in the bulk form, the band is continuous. The valence band energy and the conduction band energy levels are continuous. Both are separated by a forbidden gap. But in the case of semiconductor nanoparticles, the valence and conduction band energies are not continuous but discrete, fine structure we can have. If you reduce the size continuously, size of the particle, then the band gap increases. So the energy levels are confined to a certain region. So that we are calling this one as quantum confinement effect. Quantum means energy, confined means compressing. The energy levels are confined to certain region. So the width of band gap is increased continuously. If you increase the size, the opposite effect is taken place. If you reduce the size, the width of separation level is increased. Energy band gap is increased. Here the confinement is more. The fine structure is enhanced. But if you think about the bulk form, the energy is continuous, energy spectrum is continuous. But here, if you think about the system in nanoscale, the energy levels are discrete. See this. This is a size, if you reduce the size continuously, the bandwidth, the energy gap is increased. Such effect is called as quantum confinement effect. Quantum means energy, confinement means restriction to certain region. Once the energy gap is increased, the band gap is enhanced as well as the energy levels are compressed. This is possible in semiconductor nanoparticles. Such property is used in photocatalytic activity. This is called the quantum confinement effect. See, in order to expect this quantum confinement effect in the hierarchy, the size of the particle should be in a 10 nanometer range or at least 12 nanometer range, because the wave function corresponding to the electron is almost equal to de Broglie wavelength, lambda. Say we may express de Broglie wavelength in terms of 1.26 Armstrong unit. So if we convert that one into nano dimension, it is almost 12.2. So that if the size of the particle is in the range of 10 to 12, we can expect the quantum confinement effect in the better way. Now we should talk about catalysis. In the school days, you might have come across the catalyst. A catalyst is a particle which can influence the rate of reaction but cannot take part in the chemical reaction directly. But it is not correct. A catalyst may take part in the chemical reaction. It influences the rate of the equation. Finally, the catalyst may return its original strategy. There is no change in the catalyst. We can harvest the catalyst at the end of the reaction. An action where it takes part in a chemical reaction process and can alter the rate of reactions. The rate of the reaction can be enhanced without being consumed or destroyed at the end of the reaction. Initially, the catalyst involved in the chemical reaction. The involvement of the catalyst is predominant. As a result of its involvement, the chemical reaction rate is increased, enhanced. But after completion of the chemical reaction, the catalyst may return its original strategy. That means it is not destroyed during the chemical reaction. Based on the catalytic action, a catalysis can be classified as enzymatic catalyst, acid-base catalyst, photocatalyst, electro-analytic catalyst. If you think about the enzymatic catalyst, enzyme are acted as a catalyst. If you concentrate acid-base catalyst, either acid or base material is taken part as a catalyst. If you convert the sucrose into glucose and fructose, H2SO4 is taken as a catalyst. In the photocatalyst, you know that many catalysts are available. Using light, we are performing this. In electrocatalyst, platinum will be acted as a catalyst during the electrolysis process. So that many catalysts are available. For our photocatalysis analysis, we are concentrating more on photocatalysts. Before that, you should realize photochemical reaction. The chemical reaction initiated by the absorption of light is called the photochemical reaction. Suppose the reaction is carried out after absorption of light radiation, such reaction is called as photochemical reaction. In the photochemical reaction, we have to concentrate 2 points. One is primary quantum yield and another one is overall quantum yield. See, hydrogen iodide is allowed to react with the photon, which provides hydrogen and iodide. In this case, the primary quantum yield is 2, which means that due to the interaction of one photon, the number of products arrived is called as primary quantum yield. The number of specific primary products formed by absorption of each photon is called the primary quantum yield. Once hydrogen and iodide are formed as a result of absorption of one photon, then the formed hydrogen is once again interacted with the hydrogen iodide and provides H2 and iodine. Then 2I gives I2. In this process, the hydrogen iodide is reacted 2 times, so that overall quantum yield in this case is capital F is equal to 2. As a result of interaction of photon, then number of times a reactant molecule reacts is called overall quantum yield. So in this reaction, overall quantum yield is 2. So this reaction is photochemical reaction. See this photocatalysis. In this case, it's taken place in our everyday life. With the help of sunlight, the chlorophyll existing in the leaves, at the same time with the aid of carbon dioxide and water, produces starch. That means organic matter as well as oxygen. Here the chlorophyll is nothing but chlorine magnesium ligand. If you observe the tree, which is always green in color, because when the leaves are allowed to interact with the sunlight, it absorbs only blue and red light. Green light is scattered or reflected. As a result of it, a tree is looking like green. It doesn't absorb the green light. During the sunlight irradiation, the blue and red lights are being absorbed by the leaves, but the green light is reflected. It is not absorbed. As a result of this, the plants are appearing green in look. So this is called natural photocatalysis. With the help of this, we are getting oxygen as well as starch. Now, to enter into the process of photocatalysis, we should be familiar with the Dirac-Hole theory. Without understanding this Dirac-Hole theory, we cannot discuss the process of photocatalysis. Mechanism will not be cleared. You know that in quantum mechanics, say in the non-relativistic quantum mechanics, the Schrodinger equation is available with you. That is HSI equal to E psi. H is the Hamiltonian, which is minus h cross square by 2m del square plus v. E is the energy operator, whose value is IH cross dou by dou t. In this non-relativistic Schrodinger equation, the space coordinates position x, y, z are expressed in second order. We are using the operator del square, but the time is expressed in first order, dou by dou t. This contradicts space-time symmetry requirement of the special theory of relativity. So to overcome this problem, we have to express both the space as well as time coordinates either in first order or second order. To solve this problem, Klein-Gordon attempted to present an equation called the Klein-Gordon equation, which both the coordinates space and time are expressed in second order. But Dirac attempted to propose an equation in which both the coordinates space and time are expressed in first order, which is called the relativistic quantum aspect. He proposed a Hamiltonian H equal to C alpha dot P plus beta MC square plus V of R. For a free particle, the Hamiltonian is H equal to C alpha dot P plus beta MC square. If you explain the energy in the Klein-Gordon equation, also we can have both positive and negative energy for a particle. But Klein-Gordon failed to explain the occurrence of negative energy state. But Dirac explained the occurrence of negative energy state in a beautiful way. He introduced a spectrum like this, in which a particle has both positive and negative energy. Then both the energy levels are separated by the forbidden gap of width 2mc square, in which no energy level can exist. The positive energy spectrum starts with plus mc square and ends with plus infinity, and the negative energy spectrum starts with minus mc square and ends with minus infinity. Then both the energy levels are separated by the forbidden gap of width 2mc square, in which no energy level can exist. Here in the case of semiconductors, we are calling this as forbidden gap. This is valence band region, this is conduction band region. This is energy gap, forbidden gap of width 2mc square. This theory was proposed by Dirac. Suppose an electron in the positive energy cloud is trying to come to the negative energy C, such a transition is not allowed because electrons are filled on the energy levels on the basis of Pauli's exclusion principle. No two energy levels can occupy the same electron. That means no two electrons in an atom can exist in the same quantum state. So one energy level may accommodate only one electron on the basis of Pauli's exclusion principle. In the case of negative energy C, all the energy levels are occupied by the electron. So the transition of any one electron from the positive energy level to negative energy level is forbidden. However, if you provide an amount of energy equal to or greater than the width of the barrier, any one of the electron in the negative energy C may make a quantum jump to the positive energy state and thereby leaving a hole here. Suppose if you provide energy which is greater than or equal to the width of the forbidden gap, then this electron in the negative energy C will make a quantum jump to the positive energy state and thereby creating a hole. In this way, a pair is created. See this? Creation of hole means removal of certain amount of negative energy and charge and is equivalent to the creation of same amount of positive energy and charge. Please try to understand. If you apply photon of energy which is greater than or equal to the forbidden gap of width 2mc square, as a result of this excitation, an electron in the negative energy will make a quantum jump to positive energy state and thereby creating a hole. Creation of hole means removal of certain amount of negative energy and charge that is equivalent to creation of the same amount of positive energy and positive charge. In this way, a pair is created. This is called Einstein mass energy equivalence. Energy is converted into mass equal to mc square. But if you think about in this way, more and more hole and electrons are created, there is another probability as well as possibility for a hole to meet its antiparticle electron. Once a hole is allowed to meet with its antiparticle electron, immediately the pair is annihilated. As a result of it, energy is liberated. Here, the mass is converted into energy. Pair creation is energy is converted into mass. Pair annihilation is conversion of mass into energy. Mass energy equivalence. This will explain the concept of death. If you think about a mass particle, it is bearing the soul. If I am alive, the soul is present inside me. After my death, the soul comes out. That is, energy is liberated, mass is dissipated. Equal to mc square. Einstein mass energy equivalence. In the photocatalytic activity, these are all called, in the semiconductor, these are all valence band, these are all conduction band. This is energy gap. So, to produce the photo-generated charge carriers, we need photon of high energy. Once the charge carriers are generated, we should not allow the charge carriers to recombine. Once the charge carriers are recombined, there is no talk about the photocatalysis process, no use of it. So inhibition of photocharge carriers is very, very important in photocatalysis. So to explain photocatalysis in a better way, we should know about the Dirac hole theory. Hole itself is nothing but positron, antiparticle of electron. So in this way, using Dirac Hamiltonian, we can explain the formation of electron and hole. So that to conduct photocatalysis in the better way, we should not allow the photo-generated charge carriers to recombine. The recombination of photocharge carriers should be inhibited. Once the charge carriers are not allowed to recombine, we can conduct the photocatalytic activity in a better way. See, this figure explains, this diagram explains simple electrolysis. Say that this is TiO2 electrode, working electrode. This is platinum counter electrode. The electrolyte is water. We are talking about the water splitting. TiO2 is a semiconductor material whose band gap is 3.1 electron volt. Say, if you consider the water splitting, the external power is applied. Redox reactions are taken place. Oxidation and reduction reactions are compulsorily taken place. Both the reactions are taken place. Then only we can conduct photocatalytic activity. In the case of metals, either oxidation or reduction will be taken place. But in the case of semiconductors, both oxidation as well as reduction reactions are taken place. With the help of oxidation and the reduction reactions, we have to convert water into hydrogen and oxygen. Then oxygen is collected in working electrode, then hydrogen is generated in the counter electrode. Then oxidation means liberation of electron. Reduction means gain of electron. To understand this process, you should remember a simple formula: oil rig, OIL, oil, RIG, rig. Oxidation is liberation. Reduction is gain, rig. RI is OIL, oil, rig, RIG. In the case of oxidation, electron is liberated. In the case of reduction, electron is gained. Both oxidation and reduction, which is called as redox, reactions are taken place. In the case of TiO2 electrode, it has valence band as well as conduction band. If light is allowed to pass, then which creates holes and electrons, that is photo-generated charge carriers. These generated charge carriers can be allowed to react with hydrogen and oxygen. Then they may produce free radicals. That generated free radicals can destroy the toxic materials. We will discuss the mechanism in the forthcoming slides. See this. In this process, water is taken, that is separated to H plus OH minus with the help of biasing. Once H plus and OH minus is taken, then oxidation and reduction reactions are taken place. As a result of oxidation and reduction reactions, H2 and O2 are generated. At the same time, then the generated H2 and O2 are used to create free radicals. The generated free radicals can remove the toxicity existing in water. The steps involved in the photocatalysis process are explained in the gradual manner. Then we will go to the mechanism part. First of all, generation of electron and hole with the sufficient potential for water splitting. For that, light is allowed to fall on the semiconductor materials. Then charge carriers, electrons and holes are generated. Then the generated charge carriers are not allowed to interact. They should be separated. Then the separation of charge carriers and the migration of the charge carriers to surface reaction sites is very, very important. Once the charge carriers are reaching the surface reaction sites, then we have to construct the sites for H2 evaluation and O2 evaluation, so that simultaneously we have to promote oxidation and reduction reactions to produce O2 and H2 respectively. Finally, with the help of O2 and H2 and electron and holes are used to generate free radicals and then breakdown of organic matter to carbon dioxide and water. See this mechanism. Water electrode TiO2 is used, and then platinum is the control electrode. If you take the water H2O, with the help of external biasing, water is separated to H plus and OH minus. This is the first equation. Then reduction reaction is taken place. Reduction is gain of electron. Then 2 H plus ions gains 2 electrons and H2 is arrived. Then OH minus is subjected for oxidation. That means 2 OH minus interacted with 2 H plus. Oxidation means liberation of electron. That means gain of positron. So 2 H plus positrons are allowed to interact with OH minus. As a result of it, H2O and half O2 is generated. Here, reduction process, hydrogen is generated. During the oxidation process, oxygen is produced. Water is separated to H plus and OH minus with the help of external biasing. Then both redox reactions, that is oxidation and reduction reactions, are carried out in the electrolysis process. During the reduction reaction, reduction means gain of electron, so that H plus ions gains 2 electrons. As a result of it, H2 is generated. Then OH minus ions gain 2 positrons. This is oxidation reaction. Oxidation means liberation of electrons. That means gain of positron. Then water and O2 is generated. Then the created H2 and O2 are useful to produce the free radicals. Once the O2 is allowed to interact with the electron, which produce O2 minus, that is superoxide anion, then superoxide anion is allowed to react with H plus, then hydrogen superoxide is generated, then two hydrogen superoxides are allowed to interact. As a result of it, H2O2, hydrogen peroxide is generated. Once again, an electron is allowed to interact with the H2O2 and produces hydroxyl radical, OH dot. Then the hydroxyl radical react with pollutant. As a result of the reaction of hydroxyl with the pollutant, carbon dioxide and water are generated. This actual mechanism involved in this hydrolysis of water. So initially, we are producing hydrogen and oxygen. These produced hydrogen and oxygen are allowed to interact with the photogenerated charge carriers, electrons and holes. As a result of it, free radicals are generated. The generated free radicals are allowed to interact with the pollutant, and the pollutant is decomposed into carbon dioxide and water. This is a total mechanism involved in photocatalysis process. Say, we should know the meaning of the word free radical. What is free radical? Free radical is energy hunger. A free radical is a molecule or molecular fragment that contains one or more unpaired electrons in its outermost orbital. A free radical is generally represented by superscript dot, O2 dot, O2 minus dot, OH dot, so that we are representing a dot. That dot represents it is a free radical. That means outermost electron, outermost orbit are in the deficit of electrons. They need energy. Free radicals are like robbers, which are deficient in energy, so that they seek energy from other systems. Free radicals attack and snatch energy from other cells to satisfy themselves. In this way, free radical absorbs energy from the dye molecules and the degradation is taken place. See that water itself is acted as a free radical. From water, we can generate the free radicals. The mechanism involved with the free radical generation from water is described in the following way. If you think about water is having HOH, that means two OH bonds are available in water. The space of OH bond can be divided into three parts. One is S region, and another one is overlapping region, and the third one is P region. S region is especially made for hydrogen bonding, and the P region is especially made for oxygen. Then the overlapping region is the region specified for bonding. Suppose the two electrons are taken for our consideration. When the two electrons are in the bonding region, then HOH bonding is present. You may get the HOH bonding. Say, among the two electrons, these two electrons are present in the P region. That means in the oxygen region, no bonding is taken place. In this way, H plus and OH minus are attained. That means no H2O molecule is formed. You should be clear with this. The hybridization taking place in water is sp3. In the case of water, two electrons are existing in the unbonding state. Suppose the two electrons are present in the bonding region, HOH is formed, water molecule is formed. Suppose the two electrons are in the P region means closer to oxygen, then the water molecule is separated into H plus and OH minus. Suppose the two electrons, among the two electrons, one is in the S region and another one is in the P region. Now, free radicals are generated. That is H dot, then OH dot. Free radicals are generated. But these free radicals are not stable because the separation of these two free radicals are not extending for long run, because the distance of separation is very short. Immediately, then the free radical is changed into H2O molecule. Just pay your attention to understand this hybridization process. There are two OH bonds in water molecule, HOH, OH, two OH bonds are existing. The space of OH bond can be divided into three parts and are A space. A space is meant for hydrogen, and P space, that is meant for oxygen. These two are subject for overlapping, that is called overlapping space. A space, P space, overlapping space. Two electrons are existing in the system in the unbounded state. Suppose the presence of two electrons are taken for our consideration, that provides whether the water molecule is formed or not, or the water molecule is converted into free radicals. The first case is when the two bonding electrons appears in the bonding space of water. Then bonding space, water would be presented in the common style HOH. If two electrons are existing in the bonding space, water molecule is formed. When the two bonding electrons appears in the P space, both the electrons are existing in the P region, that P region is closer to oxygen. There is no electron occupying the bonding space, then bond would be temporarily broken, generating a hydrogen ion and a hydroxyl ion. So H2 is separated into H plus and OH minus. And the third case is when one bonding electron appears in the S space, that means closer to hydrogen, and at the same time another bonding electron appears in the P space, that is closer to oxygen. There is no electron occupying the bonding space. No one electron is existing in the bonding space. Therefore, the bond would be temporarily broken, generating hydrogen radicals and hydroxyl radicals. So water would be presented in the radical style like H dot and OH dot. So the water is converted into free radicals, hydrogen radical, hydroxyl radical, but this is not stable for long run. We cannot utilize this for long run because the distance of separation is very less. So immediately they may combine and provide water molecules. Now, in order to create the free radicals in water, we have to apply electric field. Once the electric field is applied, that OH minus dot hydroxyl radical is making its orientation to a desirable direction and is separated from H dot. Once OH dot is separated from hydrogen, we can get true free radicals. That is a statement I have given here. In general, the distance between the radical is very short. The generated hydroxyl radicals and hydrogen radical combine swiftly, quickly, while under an electric field, the electric field force might cause a directional rotation of the hydroxyl free radicals, which might lead to the separation of the hydrogen and hydroxyl free radicals and produce true free radicals. So the true free radicals are generated. So in this way alone, we can create free radicals from water. Under the action of electric field alone, the water is separated into free radicals. Otherwise, no talk about the generation of free radicals, so that we have to maintain higher potential, so that the necessary condition for the production of photocatalysis is the potential above the conduction band should be more positive, and potential above the valence band should be more positive, and potential below the conduction band should be more negative. Then only we can achieve this strategy. The factors affecting photocatalytic activity include particle size and shape, initial dye concentration and catalyst dosage, stirring and reaction mixture, effect of reaction temperature, effect of energy and intensity of radiation source, effect of oxidants, then effect of pH value of the solution. These are all the factors affecting photocatalysis of a substance. Say, as a particle size decreases, photocatalytic activity of a photocatalyst is expected to increase. Because of increase in the surface area, therefore, the number of active sites available for reaction could be increased. Our aim is we should not allow the photo-generated charge carriers to recombine. Once the charge carriers are separated, then the charge carriers are allowed to interact with the dye molecule. As a result of that interaction, the free radicals are generated. The generated free radicals may consume the dye molecules, and finally the degradation takes place. So the role of the catalyst is to prepare more and more photo-generated charge carriers, and the produced charge carriers are to be absorbed by the surface. Then the dye is allowed to interact with that, and degradation will be taken place. As a particle size decreases, photocatalytic activity of a photocatalyst is expected to increase. because of the increase in the surface area. Once the surface area is more, the number of active sites available for reaction could be increased. Then increasing the concentration of the dye more than the optimum level lowers its removal rate for the following reasons. If you increase the concentration of the dye, the catalytic activity may not be increased, that may be suppressed. With the increase in dye concentration, light absorption increases in accordance with the Beer-Lambert's law, that is absorbed rate equal to ABC, absorption coefficient, path length, and concentration of the solution, so that more photons get precluded from reaching the catalyst. They are not allowed to reach the catalyst, especially the catalyst is available in the interior. The dye alone absorbs more amount of light radiation, so that the light radiation is not actually allowed to interact with the catalyst. As a result of this, the catalytic activity will be reduced. So this light absorption would abate the charge carrier generation and efficiency of degradation. Once the light is allowed to interact with the catalyst, the charge carriers are generated. Otherwise, there is no talk about the creation of charge carriers. If the concentration of the dye is increased, then they may absorb the light totally, and light energy is not allowed to interact with the catalyst. We should allow the catalyst to interact with the light radiation. That is very, very important here. Especially, the dosage of dye is varying from 30 ppm to 50 ppm. ppm stands for parts per million, which means 30 microgram per ml or 30 milligram per liter. If you dissolve 30 milligram per liter, we can expect better degradation ability. At the same time, if you think about the dosage of catalyst, that should be 0.5 gram per liter. This is the prescribed dosage. If the ratio is chosen in this aspect, the dye quantity should be varying from 30 to 50 ppm, which means that 30 milligram per liter to 50 milligram per liter. The dosage of the dye is 0.5 gram per liter. This is the prescribed dosage. If you make your presentation, if you make your analysis process using this proportion, you can harvest a better result. So that increasing the catalyst loading may enhance the rate of dye removal because of the corresponding increase of dye absorption capacity and the number of available surface active sites, which facilitate the generation of free radicals. However, adding more catalyst than optimum level can hinder the rate of catalysis owing to formation of particle agglomeration and scattering of light due to solution turbidity. If you add more quantity of catalyst, the solution is having high turbidity. As a result of it, light cannot be absorbed by the catalyst, but light is scattered. So to avoid this problem, we should use the optimum level of catalyst, which is of the order of 0.5 gram per liter. Then aeration and stirring, these are all very, very important process, but usually we won't do. Bubbling oxygen gas or air into the reaction mixture and stirring are the two important factors that can influence the degradation efficiency of dye. The presence of dissolved oxygen in the solution enhances the efficiency by separation of photogenerated electron hole pairs via capturing conduction bands electron to produce free radical O2 dot minus and OH dot radicals. So that if the level of oxygen is more, that can generate more hole and electron pairs, and the created hole and electron pairs are allowed to interact with the dye, and the degradation is better. If you think about the photogenerated electron hole in the case of ZNO, then oxygen generation, O2 dot generation is reduced because the conduction band level of ZNO should be more negative than that of reduction potential of oxygen versus NHE, that is normal hydrogen electrode is taken for standard. If you use normal hydrogen electrode as standard, then bubbling of oxygen will influence the rate of degradation. Otherwise, the reaction is taking place in the slower aspect. Stirring is another one factor. Stirring the reaction mixture during photocatalysis study, also improving the degradation rate due to the following reasons. Firstly, stirring enables more oxygen to dissolve in solution due to turbulent motion caused by agitation. We are separating the molecules by the way of stirring. At the same time, fumes are generated. Secondly, it fastens the rate at which dye molecules move to the catalytic surface via diffusion and the mass transfer mechanism. Suppose stirring mechanism will not be taken place. At a particular region, the dye molecules may accumulate in higher order, and one region there is no dye molecule may be present. To enhance the proportion of dye molecules in the better way, we should improve the stirring process. The stirring process is faster. The dye molecules may move and reach the catalyst surface through diffusion and mass transfer mechanism. So stirring is also very, very important. Then reaction temperature. Generally, with an increase in reaction temperature, degradation of dye may be enhanced due to increased oxidation rate. The oxidation rate can be enhanced at the solid solution interface. And another one, second point is inhibition of charge carriers recombination. At high temperature, the charge carriers not allowed to recombine. Once the charge carriers are not allowed to recombine, we can expect better photocatalytic activity. And the third condition is increase in the number of cavitation bubbles, which promote the formation of free radicals, which means the static pressure of the liquid is varying than that of its vapor pressure. So the fumes are generated inside the solution. As a result of it, the degradation ability will be enhanced. So the reaction temperature is very, very important. However, the reduced dissolution of oxygen and absorption of organic species at a high temperature decreases the rate constant of the reaction. So that we should maintain the temperature under the controlled rate. If the temperature is exceeding a normal value, then the situation is entirely changed. Instead of harvesting enhanced photocatalytic activity, the activity can be reduced. So that we should perform the experiment at least 60 degrees Celsius. Then energy and intensity of light source. It plays an vital role. Once the light energy is the deciding factor, in the case of UV absorption process, we are going to calculate the wavelength emitted. Using that, you are calculating the band gap value Eg by the formula E equal to h nu, C equal to nu lambda, that is hc by lambda. Then while fixing the excitation wavelength for photoluminescence, PL, we are asking the excitation wavelength. If you are providing the excitation in the UV region, say 325, you may be expecting the emission in the visible region. Such emission is possible as a result of recombination of the charge carriers, electrons and holes. So that if the PV intensity is, PL intensity is very low, we can expect more photocatalytic activity for that sample because the recombination is hindered. If you use the visible light, UV light, then the emission is expected in the visible region, so that energy gap is justified on the basis of wavelength. If the energy gap is more, the energy needed to promote the pair, that means whole electron, is also more. So the intensity as well as the frequency of the incident light is very, very important. That means energy is h nu, that means frequency of the incident light, as well as the quantity of light, intensity of light. Both the factors are very, very important. Usually for the practical applications we are using as sunlight. Sunlight carries only 5% of UV radiation, so that if you perform the experiment with the help of UV light, the activity can be enhanced. But for practical purpose, we are motivated to utilize the sunlight, even though it has only 5% of UV light. For that, the catalyst should be enhanced by the way of doping or composite formation. We should provide some modification in the band gap energy, which means that we have to collect more and more photo charge carriers. The generated photo charge carriers are accumulated in different regions, different energy levels. We should not allow the charge carriers to combine. If they are combined, the activity may be reduced. We should not allow the system to combine. At the same time, we have to generate more and more photo-generated charge carriers. For that, we need high energy incident light. So, intensity of the light as well as the energy of the light are two factors which may be enhancing the catalytic activity. In that way, you have to choose. And then oxygen, such as H2O2. Oxygen means donor of electron. If you add H2O2 while the reaction is taking place, the photocatalytic reaction is going on. If you add a few drops of H2O2, that can enhance the photocatalytic degradation process of the catalyst. So the catalytic activity can be enhanced. And then for providing modification to the catalyst, we are using doping, co-doping, and composite formation. Although these histories are known to you, pure Residano is an efficient photocatalyst for the decomposition of many azo dyes. Due to its photosensitivity and catalytic properties, its catalytic efficiency is limited by factors like fast photogenerated electron hole recombination. That means the generated charge carriers are immediately recombined. We should not allow the photogenerated charge carriers to combine. If you won't allow the photogenerated charge carriers to combine, we can harvest better photocatalytic activity. So that poor accessibility to visible light owing to its higher band gap energy. The band gap of Z0 is almost 3.2 electron volt, so that we need UV radiation. With the help of sunlight, we cannot perform it. So to harvest better result, then the charge carrier transport should be enhanced, surface active site should be enhanced, then generation of charge carrier should be enhanced. All the properties are to be modified. So this problem can be sorted out in two ways. Only one with the help of doping or co-doping, and another one way is coupling with another one semiconductor. That means composite formation. Doping refers to the introduction of impurities into an intrinsic semiconductor to change its properties. Composites may be defined as multi-component systems made of two or more chemically and physically different phases separated by distinct interface, which are deliberately combined and have structural and functional properties different from any of the individual components mixed. When Z0 is doped with appropriate amount of atoms, dopant elements, its catalytic activity is increased. Firstly, the impurity atoms hinder the electron hole recombination. The role of impurity in the Z0 is it doesn't allow the recombination process taking place in the photogenerated charge carriers. So, because they are acting as their trapping sites, they trap the charge carriers separately, so that the recombination of electrons and holes is highly forbidden. In the case of composite, the separation is achieved due to the interfacial transfer of photogenerated electrons from the conduction band of one semiconductor to the conduction band of other, and the diffusion of valence band holes in the reverse order in a expected manner through the band gap structure, and build up inner electronic field in a p-n heterojunction structure. So inner electric field is generated. That electric field does not allow the combination of both electrons and holes. In this way, we have separated the photogenerated charge carriers in the case of composite system. If the system is doped, they are used to the doped materials are used to absorb the photogenerated charge carriers. Therefore, the photogenerated charge carriers are not allowed to recombine. So anyway, in the photocatalytic process, the electrons and holes are generated with the help of light, and the generated charge carriers are not allowed to recombine. Once the charge carriers are generated, they may produce hydrogen and oxygen through the water molecules. Then the generated hydrogen and oxygen molecules are used to generate free radicals. Superoxide anion and hydroxyl peroxide, or hydrogen superoxide or hydroxide free radicals. These generated free radicals are energy hungers and are allowed to react with toxic materials, say dyes. Finally, the dye is subject for degradation. As a result of it, carbon dioxide and water are harvested. In this way, we may perform the photocatalytic activity. It's a simple opening session regarding the photocatalysis process. If you make your attention deeply, then we will enter into the actual mechanism involved with the help of the compounds by the way of taking that consideration of activity existing in TiO2, ZNO, and doped TiO2, doped ZNO, then composite form we can explain. So that anyway, I have given some little bit information regarding the mechanism actually involved in the photocatalytic activity and photocatalysis. Then you can understand a little bit about it. I hope so. Thank you. Hello.
I wish to express my gratitude to Dr. N. Shanmugam, Assistant Professor, Department of Physics, Annamalai University, for providing encouragement at the topic of photocatalysis of semiconductor nanoparticles. He quoted many examples and would like to express gratitude to you, dear sir, for exposing your knowledge to this topic. It was well clear. Thank you very much, sir.
Thank you.
Now the oral presentation session starts right now. Well, since everyone is here, we will start our program. It is my pleasure to welcome our chairperson, Dr. R. Eril Pavai, Associate Professor, Department of Physics, Thiruvalluvar Government Arts College, Viruthachalam. I am honored to invite you to be the chairperson. She has more than 27 years of experience, 17 researches, 5 PhD guided for the scholars and completed, and 2 ongoing PhD, and the citation is above 1,000. She is the person who always guides the students in all her experiences. We are fortunate to have you, dear ma'am. Now, I would like to call our chairperson to take over this session. Welcome, ma'am. First presentation starts Dr. S. Seduraman, guest lecturer of zoology, Hariniyar Anna Government Arts College, Namakkal, Tamilnadu. Welcome, sir.
Thank you, ma'am. Very good morning. Ma'am, it is audible. Hello.
Yes, audible, audible. Welcome. Thank you, thank you.
It's my pleasure and privilege to present my research topic on your exchange, St. Joseph University. And also I thank the convener and higher authorities of St. Joseph University. Let's start my session. My research topic is screening and evaluation of molecular studies on the selected tissues of pumpkin beetles. Normally we can call it as the order of insect orders. Coleoptera, the classes Isomelidae. Here the presentation slide. So this is a research topic I've already mentioned. Then start the introduction. The cubra of beetle represent one of the most diverse lineages of Earth. It is mostly derived in many scientists. About 350,000 species were up to date recorded. Cryptomelidae is commonly known as leaf beetle, and it is the order of Coimbatore, the largest genus of this kingdom. So leaf beetles, especially the species of, I have research done in the two species. One is Alcophora nigriphanis. Especially it is a plant pest. It is known as tropical and subtropical. We can find out easily. Okay, very smallest one and very tiny insect. Especially it is in the pumpkin beetle, also known as pumpkin beetle. Especially pest foliage or severe foliage on that leaf. Okay, the pumpkin beetle is widely distributed to the especially in Bangladesh, Pakistan, Afghanistan, and Ceylon, in the China, like that. So the beetles, what is the life cycle? It is 12 to 30 days. Then, what is the size of the beetles? Means I already told the tiny, very very insect. That means the what is the length? It means 7 mm and 2.6 mm broad. It is what is the feeding stage? It means the adult feeding for 8 to 9 weeks. The plant finally turns into once it will attack in the, this pest will attack the completely. It attack on the it could be especially in cover or pin. It will completely turn onto brown color. Okay. Then the next insect, Nanomaterials, is fully black with orange color, about 6 mm. When compared to that Focolis, is very less than size. Especially in what is the size of it means 6 mm and 1.8 millimeter broad. Okay, it occurs in the Indian families of especially in Coimbatore family. Depending, it will go another and feed of the leaf means it already salt content, vitamin content is more. Then only it will go on another and it will west. The pumpkin beetles and nigripanis are serious pest in vegetables. An adult feed on leaves and in some cases of food while group of attack in the root. Some insect are grouped into attack in the leaf, or some are make bury under the soil, and it will go and occur in the root of the that forgive family. Okay, here is the next slide. My research objectives to amplify the in insect taxonomy. Finally, first step to identify the pest species. What is the type of pest and what is the morphological structure? You have to see. Here's my objectives of research to amplify DNA sequences with unique prime DNA and tissues of Vicolis and Nagitmanis using PCR, polymerase chain reactions, and to identify the second objective and to identify the pest species of DNA barcode. Especially, I have used the cytochrome oxidase G of this one gene. Here is the materials and method. I have followed the methodology for 1994. The DNA extraction whole insect specimen I have chosen the methodology format all. In 95 to 100% of I have stored in the ethanol and 26 I maintain the DNA extraction using cogen kit. According to this manufacturer instruction, all the DNA samples were acted for because the DNA then only can be separated. Okay. Then you have transferred the DNA concentration as standard to a PCR analysis. And here is the result of PCR reactions. The genomic DNA and PCR product of Fovicolis, the genomic DNA generator 6 band in Fovicolis. We have separated the forward primer and backward primer. In the forward primer, the DNA sequence of Fovicolis in electroporograph. I have shown the figure. Come in the next slide. The amplitude 658 base pairs spike band of coding gene was obtained from Fovicolis. The sequence of taken out and we have listed in the NCBI database. The cytochrome gastritis primer used the coding primer are used to in this study. I was given the DNA coding in the next slide. Here is the DNA PCR product. The database of identification when present sequence did not match, especially negative insect. The barcode previous. Now, what is the present studies? I have chosen the Japanese barcode. There is no match between NCI database. First to submit because of Nagripanis in NCBI database. There is no record. Previous record, previous record is not in NCBI database. I have been the first to submit the sequence of this insect barcode. Okay, this the next DNA barcoding aims to both enforce the global standard and coordinate research in DNA barcoding. Formal region proposed for the standard barcode is a cytochrome oxidase gene. Means so use this mitochondrial gene. The mitochondrial gene is used for to separate the DNA band and the insect morphological identification and the genetic level variations. So the next point, single species identification is the historical fundamental of DNA barcoding. Finally, DNA barcode is multiple species of identification. It is used to identify the code sequence. Adenine, guanine, like that. So this we can identify with the use of this DNA barcode. We can identify the single taxonomy and insect taxonomy orders and the taxonomy sample for biodiversity. Then this coding begins by correctly amplified and sequences in the gold blast. It matching identification the similarity of 90 to 100%. So the sequence were compared with the online database, NCBI databases, and no mismatching is not occurred. So blasted also identify the species sequences 90 to 100% of maximum identity. So the next, the molecular identification allowed to correctly group of the specimens in the same order obtained with morphological identification with the great assurance. The use of DNA barcode. So the sequences from Fovicolis is blasted insect sequences and identification the chrysomelis of Fovicolis. Is I have used these sequences. I have separate the sequences with the derivative of DNA barcode. In what is the matching ID? It means here is the ID sequences in the already recorded in the NCBI databases. This is the PCR gel band for using the primer of cytochrome, the oxidase 1 gene primer, and the Fovicolis insects having 6 band and Fovicolis having 8 base pairs. Regarding this, we have chosen the forward primer and backward primer, the 5 and 3 like that. So this is the sequence of DNA binding studies. This is a forward backward primer DNA applications. The color key alignment scores of DNA barcode. This DNA sequences identify the NCBI databases list. This is a picture shows the already previous record. I have matched the databases. This is a reference of references. Here we can find out one is Fovicolis. 9 identify the matching correct sequence matching is 99%. Okay, the sections of coding number KB898252.1. Then next inside Nigripenis DNA barcoding of Nigripenis. The same way I have chosen the whole insect or whole tissue. I have chosen the cytochrome oxidase 1 gene primer, and I have go for the DNA band alignment sequences. I have the NCBI database. There is no matching in the NCBI databases. In this case, Agripenis in the present study have been the first to report the sequence of Agripenis from Parasuraman species. This is the first DNA barcode sequence in the databases. First to report the sequences. So this present study only databases regarding species identification is attempt for the first time. In that, the quality of sequences and comparisons deposited in the this Parasuraman family. Again, LCO primer, forward and backward primer. This is showing this graph. This is DNA barcode alignment scores, and the next figure DNA sequences identified in the NCBI databases instead of Caroliensis. This is the order of this Alcobra species. This sequences matching identified in the NCBI references. This is in this databases there is no recorded in Parasuraman species, especially in Nigripenis. There is no matches. Especially this is not done. Finally, my conclusions. The studies are focused on the 2 species of Parasuraman, Fovicolis, Ioprophoricus, and Ioprophora nigripenis. The observed result exhibiting similarities in the characters has been shown to generate the close relationship between the 2 species, whereas some of morphological and physiological variations may be phylogenical transformation among the species level. The both insects I have done the morphological level up to the morphological changes. In the morphological changes so the genetic sequence variations is similar. So the next level to identify the phylogenic transformation the among the species. Thank you.
So good afternoon to all. I am Dr. R. Elipavai. First of all, I thank to St. Joseph authorities, Nagaland, for giving this opportunities. Seduraman, So what are the special features of your findings?
Special features. It means
Yeah.
the morphological variations is any occurs in the insect means I have chosen the genetic variations. Whether is any occurs genetic variation in the insect. Like so I have chosen the variations is no similar.
Okay. Any questions from audience? Any questions? If you have a doubt, unmute your mic and ask the questions. Nice presentation, Seduraman.
Thank you.
Go next, second one. Call second one.
Thank you, sir. The second presentation, T. Grija, Department of Physics, Vivekananda College of Arts and Science for Women. Welcome, ma'am. Sorry for the inconvenience. The third presentation, Shistu K. Donglu, Department of Zoology, St.Joseph University, Dimapur, Nagaland. Welcome, ma'am.
Sorry for the inconvenience. I hope I'm audible to all.
It's audible.
Okay. A very good morning to you all. Firstly, I thank the Department of Physics for giving us such an opportunity to present our paper. Well, my name is Chize and I am currently doing my Ph.D. research work under the supervision of Dr. M. Murali, Assistant Professor, Department of Zoology from St.Joseph University. And today I will be presenting on this topic, FTIR study of bakery yeast degradation of polyethylene terephthalate bottle waste. This is the abstract. A large quantity of plastic waste have been accumulating in the environment, which disturbs the ecological balance of the earth. So eco-friendly technologies need to be devised to solve this problem. In this present study, the degradation of PET plastic is being carried out with the use of bacteria yeast under laboratory conditions, and then further observation of FTIR and SEM analysis have been observed. We are all aware of the current scenario created by the overuse of plastics in the environment. Plastics are so essential in our day-to-day life that it has become an integral part of our economic life, which has made our work as well as our life easier. These plastics comes in different forms and different types, and one of it is the PET, polyethylene terephthalate. So this polyethylene terephthalate is a thermoplastic polymer having applications in numerous fields. However, the excess use of this plastic in the environment has now become a very big issue. Also, scientists and researchers have been working on to solve the problems caused by the environment. Yet, the problem is unsolved. And however, many researchers have got the idea of introducing microorganisms in order to degrade the plastics. So, in this present study, we dealt with the degradation of PET plastic with the actions of bacteria yeast done under laboratory conditions, and further biodegradation process were carried out with the help of FTIR and SEM analysis. So, this slide is about the materials and methods. The important materials which we used were the PET plastic bottles, the PDA broad medium, and also the bacteria yeast. The PET plastic bottles are plastics are those ordinary drinking bottles which we can easily get it from the shop. So these kinds of plastics were cut it into small pieces for about 1 centimeter, and after cutting into small pieces, it was washed with 70% ethanol. After that, again, it was washed with distilled water, and finally the samples were kept for drying. After drying, some samples were directly inoculated into a PDA broad medium. That PDA broad medium containing the bacteria yeast. Some were directly inoculated into that medium, and some were kept untreated for a period of about 1 month. And after 1 month, those two samples were sent for FTIR and SEM analysis. So for FTIR analysis, measurements were carried out with a Perkin-Elmer spectrum 2, and spectra were recorded at the resolution of 2 per centimeter. And for SEM analysis, VECA 3D scan was used, and analysis were carried out using low vacuum 0.68 Thor mode at different magnification level. Coming to the results and discussion, from the experiment which we have performed, from the SEM analysis method, we have found that the two samples, that is, one is the treated one and the other one is untreated. So the samples which we have treated with the bacteria yeast, in that sample, colonization of yeast have taken place. Whereas the other sample, which we did not treat with anything, in that sample, there was nothing. There was no colonization of yeast or any bacterial or any fungi colonization. There was nothing. This is evident from the pictures shown here. This is the comparison picture of the treated samples as well as the untreated samples. The left side of the sample shows, the left side of this image show the pictures of the samples which was not treated with bacteria yeast. And the right side of the picture shows the samples which were treated with the bacteria yeast. So comparing between these two, as we can see, in the right side of the image, we can see some white patches occurring on the surface of the plastic, and also some formations of structures occurring on the surface, as compared to the control sample. In the control sample, we do not see any such thing like that. So this is the evidence that bacterial yeast have taken place. growth of the bacteria yeast have taken place. And from the FTIR analysis, we have also found some presence of functional groups such as OH bond, also CH and C double bond O. And also we have also noticed some appearance of new peaks corresponding to CH bond stretching and CO bond. This next slide is about the FTI spectra of the control bed flags and the other sample that is treated with the bacteria yeast. From this table, we can see that new peaks have occurred. The darker shade, that is at the wave number of 2625, new peaks have occurred. Similarly, in this, two new peaks have occurred here in 1412 wave number and also 1036 bond number. And this is the picturesque view of FTI spectra. The left side shows the left side of this picture shows the that is the control sample, untreated samples, and the right side of these pictures show the treated samples treated with the bacteria yeast. So in the conclusion, I'll just run up the whole thing. In the first place, this bed plastic were collected and it was treated with a bacteria yeast under laboratory condition. After treating, it was kept in the laboratory condition for 1 month, and after 1 month, it was sent for FTIR and SEM analysis. And from the SEM analysis, we have found that some changes occurring on the surface of the treated samples, and from the FTI, we have also seen some appearance of new peaks, indicating that biodegradation of plastics have been taking place. So this study indicates that the bacteria yeast that is able to get attached to the surface of plastic samples, and it could help in the degradation of the plastic process. Also, in this details have not been done about the mechanism and also the enzyme activity. So further research has to be done in order to understand the mechanism of degradation. Thank you.
Ma'am? So I have one doubt.
Yes, ma'am.
So how does FTR helpful for the study?
With the help of this FTIR, we were able to identify those functional groups. Some functional groups. Yes.
Okay. Okay. Next. Okay. In general, what happens when continuously taken this type of battery yeast?
Pardon, ma'am.
What happened when continuously taken this type of battery yeast? Okay, tell me.
I think it will accelerate the degradation process if taken in huge amount.
You mentioned different magnification of STEM. What are the magnification you taken? Magnification level.
Yes, ma'am. It's given in the slide, but I forgot the exact numbers.
Okay. Okay. Any questions from audience? Thank you, ma'am.
Thank you, ma'am.
Welcome.
Fourth presentation is Selva Isaki, PG and Research Department of Physics, Sri Parma Kalyani College, Alwar, Kochi. Welcome, ma'am.
Good morning, ma'am. Good morning.
I am Selva Isekki, research scholar, Sri Paramakalani College, Alvarkuchi. Now I am going to give you a presentation on synthesis and fabrication of dye-sensitive solar cell using N-leaves with the zinc oxide nanoparticles at various pH values. Next, synopsis of my topic, introduction, next constituents of D.Sc, next experimental section, another one characterization and techniques, finally conclusion, then introduction of D.Sc. And D.Sc is invented by Gatesel and O region in 1991. D.Sc means dye-sensed solar cells. It converts photons energy into electrical energy. It have attracted considerable attention due to low cost, environmental compatibility, and good performance under light conditions. It is a low cost solar cells and it has conversion efficiency lower than other thin film cells. Next, components of D.Sc. There are 5 types of components present in the D.Sc. They are transparent conducting glass. Next, semiconducting photoelectrodes. Another one sensitizer. Then counter electrodes. Finally, electrolytes. TCO means FTO class substrate. Fluorine topped tin oxide. It has good electrical conductivity and good transparency. Another next semiconductor photoelectrodes. There are various metal oxide semiconductor used in the D.Sc. There are titanium dioxide, zinc oxide, silicon dioxide, and niobium pentoxide. But I have chosen zinc oxide nanoparticle semiconductor metal oxide because it has higher electron mobility and wide band gap of 3.3 electron volt, and it has non-toxic. Then sensitizer. Sensitizer is type of dyes. First one synthetic dyes, another one organic dyes. Organic dyes means natural dyes such as flowers, leaves, flowers, fruits, vegetables, roots, etc. Organic dyes, synthetic dye means ruthenium based dyes. That means such as N713, N3 dyes, black dyes, and white dyes. Next, counter electrode. Counter electrode means graphene coating. That means an cathode material such as pencil, platinum are used in the counter electrode. Next, electrolyte. Electrolyte means redox mediator. Next, experimental section, D.Sc preparation. Assembly of D.Sc. Solar cell was assembled by making paste of 3.5 gram of isotope powder added by 1 milli of acetic acid and 4 milli of ethanol, 5 milli of distilled water and 2 drop of triton X100, and then grinded by mortar. The paste was then coated on FTO glass, which has been made the mode of 0.5 into 0.5 centimeters square using doctor blade method. After the base dried, it was then heated at 450 degrees Celsius for 30 minutes, and then it immersed in dye solution for 24 hours. Another FTO glass plate was coated by using carbon from graphite pencil on its conductive surface. Then 2 drops of electrolyte solution added into the cell, and then measured the solar cell performance. Then characterization techniques. I have taken XRD, UV visible, FTIR, FESM, EDAX, and solar cell application for prepared samples. First, X-ray diffraction analysis. The synthesized zinc oxide nanoparticle are prepared using solvothermal method with a variation of pH values 3, 6, and 10. The sharp and most indent peaks observed here demonstrate that the synthesized zinc oxide nanoparticle are high crystal in nature with a single base. The strong diffraction peaks appear at 33.37 for pH 3, 36.45 for pH 6, and 36.51 for pH 9, corresponding to 101 planes matches well with all peaks show the formation of the hexagonal structure of ephemeral nanoparticles. The value of pH increases with an increase of 2 theta values. This data according to the JCBDS file number 361451. The average crystal size for a zinc oxide nanoparticle was calculated using the formula D is equal to K lambda divided by beta cos theta. K is the 0.89, it is the constant. T by Carrera is constant. Beta is the bull width at half maximum. Lambda is the X-ray wavelength. Theta is the Faraday diffraction angle. This diagram shows that the average crystalline size calculated across 60 nanometer, 43 nanometer, and 58 nanometer. Then the increases of pH value with the increase of particle size. And this shows that the increase of pH values with the increase of particle size. Then plot versus pH versus T, and the variation in beta of the dominating the theta peak 101 with increasing pH. It can be clearly seen that theta decreases on increasing pH, which implies the increases in crystallinity nature. Then analysis of UV visible spectrography. The UV visible spectra of natural dye was measured using a UV visible spectrometer. This diagram shows representative UV visible absorption spectra for the extract of henna leaves and variation of zinc oxide nanoparticle. The extraction of henna leaves dissolved in ethanol. This diagram illustrates the visible absorption spectra. The ranges between 400 to 800 nanometer for the henna leaves. Extract of henna. From the UV visible, the absorption peak of chlorophyll dye extracted at a range of 664 nanometer and 286 nanometer. Henna strongly absorbs the photons in UV and visible region of the wavelength between 250 nanometer and 700 nanometer. The band gap, the UV visible spectra is used to determine the band gap energy. So the extraction of henna dye, the band gap value of extraction of henna is 1.68 electron volt. This lowest band gap energy helps the electron to move fast from the valence band to conduction band and require less energy for the recombination of electron. It shows that the band gap energy decreasing of extracted natural dyes with the effect of the efficiency of the solar cell. And then the UV visible spectrometer of synthesized Z1 nanoparticle at the various pH value 369. The absorption wavelength ranges of Z1 nanoparticle between 200 to 800 nanometer. For 800 nanometer, as can be seen, the absorption peak increased when the pH increases from 369. Confirmed higher absorption and sharpness, it contrasts to other pH due to the fact that intrinsic band gap of ZNO is associated to electron transition from the valence band to conduction band. Next, FTIR analysis, Fourier transformation of infrared spectroscopy. It is used to identify the functional group or chemical compound. First diagram shows that the FTIR spectrum of zinc oxide nanoparticle synthesized at different pH values. These all peaks are ascribed to zinc oxide bond. The FTIR measurement confirmed the XRD result indicating the formation of zinc oxide material without any other impurities. Next graph shows that the FTI spectra of natural dyes extracted from henna. This diagram shows that chlorophyll dye extracted from henna. The strong peaks at 3340.37 centimeter inverse 1 due to the presence of hydroxyl group in stretching vibration mode, and C double bond stretching vibration shows a peak at 1734.37 centimeter inverse 1. Peaks at 1368.87 centimeter inverse 1 exhibited the CNC bending vibration. The peaks at 1043.91 centimeter and 1043.40 centimeter represent the stretching vibration of ester group, and bending of carbonate is observed at 877.58 centimeter inverse 1. The functional group confirmed the presence of chlorophyll present in the extract of henna. Next, analysis of morphology studies. FUSM analysis. FUSM is used to morphology of the zinc oxide nanoparticle at a different pH value 3, 6, 9. The grain size in this case is 200 nanometer. Crystalline size as seen from FUSM images in this case. So it is clear that the nanoparticles seen in FUSM image consist of a number of crystallite with a shape of hexagonal shape. The pH value increases with the increases of hexagonal surfaces. So these surfaces is useful to the efficiency increases in the solar cell. Then next graph is shows that the elemental analysis used for redox spectrum. So redox spectrum, chemical composition analysis, it is very useful for the research oriented. The redox spectra of isotopal sample shows the presence of zinc and oxygen element in the sample, which confirm the absence of any other impurities. Then solar cell application, the curves versus current and voltage. Then table shows that the photoelectrochemical parameter of open circuit voltage, short circuit current density, fill factor, and efficiency is calculated from the equation. It is that the open circuit voltage is 1 volt, short circuit density ranges from 0.85 to 1.09 milliampere per centimeter square. The highest VOC is 1 volt and Ks is equal to 1.09 milliampere per centimeter square were obtained from the table. We can conclude the efficiency of reached 0.36% at zinc oxide pH 9 due to the chlorophyll highly present in the henna leaf, so that efficiency was high. From the above result, the photoelectric conversion efficiency of the pH 9 with henna leaf extract is higher than the photoelectric conversion efficiency of the other zinc oxide pH value. This is because pH 9 was better than the other solar cell of pH variation due to higher surface area of zinc oxide at pH 9 has the advantages of having more dye represent the FUSM images. Conclusion: the zinc oxide nanoparticles have successfully synthesized by solvothermal method, and D.Sc have been successfully prepared from zinc oxide material with the different pH values of 3, 6 and 9 with henna extract. The synthesized samples are characterized by XRD, UV visible, FTIR, FUSM and EDAS and solar cell application. The particle size of the sample increases with the increase of pH and band gap energy decreases using the UV visible spectroscopy. The JV characteristics curves of the fabricated cell are carried out. Then the pH 9 henna leaves gives the highest efficiency of 0.39% among other pH variation of photoanodes due to low band gap energy and chlorophyll acquired. Thank you, ma'am.
Thank you, ma'am. It's a nice presentation, Silva Saki.
Thank you, ma'am.
Here, generally the glasses are thermally insulated, but here you mentioned conducting glasses. That means
FTO class plate, ma'am. Fluorine doped tin oxide.
oh, so okay. Only solvothermal method is used for preparation of nanomaterial, or various methods are available.
No, ma'am. Yeah, ma'am. Various methods available for hydrothermal, salvothermal, green
Okay.
synthesis method, etc.
Are you tried that? Are you tried? Are you prepared using that methods?
Yeah, ma'am. Yes, ma'am. I have published
Any,
two papers.
okay. Any variations between that methods? Any properties changes?
Yeah, ma'am.
Which
Size
property
changes.
is okay? Okay, my God. Any questions from audience? Because there are many researchers in this conference, please discuss with.
Okay, thank you, ma'am.
Okay, I have doubt. Silva is okay.
Silva Iseki?
Yeah, ma'am.
I'm going to ask the question.
Silva, what is the range of pH value in zinc oxide?
What is the range of?
Zinc oxide. What is the pH value?
3, 6, and 9, sir.
No, I asking about what is the pH value of zinc oxide?
What is the value? Sir, again repeat.
I ask, yes, you should understand my question. What is range of pH value in zinc oxide?
For zinc oxide.
Sir, I have chosen 3, 6, and 9 pH ranges.
No. I'm not asking about your concentration range. I asking about only pH value.
Sir, for pH 3, 6, 9.
So okay, again one more question. Is what is difference between the solvothermal method and hydrothermal method? That is, it is same. Is both the method same?
Both are methods are chemical methods, but salvothermal method was microwave irradiation using microwave oven.
Okay. So here one more questions. Yes, which study you have to confirm this zinc oxide?
What do you say?
What is your confirmation study?
Confirmation. For confirmation, sir.
I think zinc oxide. That is you took a lot of studies now, XR, FDR, XRD, and
Study for
something like this. Which study you have to confirm? FDR.
zinc oxide material.
What? I can't understand.
Zinc oxide, metal oxide mostly present in the below 500 centimeter inverse.
No, I asking about which study you have to confirm.
The size of the particle, Amaran.
No, asking about confirmation study, ma'am.
XRD analysis, sir.
I think the most of scholars you said that only the EDAX maybe. The EDAX have to present 100% of zinc oxide, right?
Yes, sir. Elemental composition analysis.
That is your sample crystalline nature, right?
Yes, sir. Crystalline nature.
Okay, what is different between the amorphous nature and crystalline nature? What is atom arrangement?
Crystalline nature, atoms are arranged in a regular periodic matter.
Okay.
Amorphous meaning class, such as class.
Atoms are arranged in irregular manner in glass nature, amorphous material. Any other questions? Okay, next. Thank you, ma'am.
Thank you, ma'am.
Thank you. Let's move on the other presentation. Fifth presentation, L. Renuka Devi, PG and Research Department of Physics, Sri Paramakalyan College, Alwar, Kuruchi. Welcome, ma'am.
Good afternoon to everyone present here.
Good afternoon.
We Research Scholar in Physics Department, Sri Paramakalyan College, Alwar, Kuruchi. Here we are discussing about the topic of structural and optical properties of pure ZNO nanoparticle. Before we start, we are going to see introduction, structure of zinc oxide, method of preparation, result and discussion. In the result and discussion, the structural properties and optical properties, and then application of zinc oxide, then conclusion. Before we start the topic, what is nanotechnology? Nanotechnology is the study of object and system at least one dimension in the range of 1 to 100 nanometer. The term nano means Greek word from which means draft, which is different from the bulk material. And 1 nanometer is equal to 10 to the power of minus meter or 1 billionth of meter. This is the size range of nanoscale between the range of 1 meter to 10 to the power of minus 9 nanometer. The introduction of zinc oxide. It is a semiconductor material of the group 2,6. It is a wide band gap of energy 3.3 electron volt and the band gap energy of 60 million electron volt. In the ZNO has been grown in various methods such as solvothermal, hydrothermal, co-precipitation method and so on. In our method, we have synthesized with the solvothermal method. The synthesized powder sample have been characterized by XRD, FT layer and UV vis. This is the structure of zinc oxide nanoparticle. In our method, the preparation has been explained. In this method, we use the zinc acetate dehydrate, urea and ethylene glycol. In the synthesis process, the zinc acetate and urea are dissolved in ethylene glycol in the ratio of 1:3 and stirred for 1 hour and heated at micro oven 1 minute per cycle and the solvent gets dried. And the solvent washed acetone to remove an unwanted organic impurities, and the obtained solution was dyed at a sunlight and get a fine powder. This is the quantitative information in the XRD crystalline size of the formula of D by Scherer equation. D is equal to H lambda divided by beta cos theta. We have already known that this equation. K is the dimensional trace factor and the value is equal to 0.9. K is the wavelength and lambda is 1.54 ampere. Beta is F with a half maxima in radian. Theta is a Bragg's equation. In this formula, we have calculated the average crystalline size. In our method, the XRD graph can be plotted in an X-ray diffraction studies. The structure can be developed for hexagonal wrist structure of a pure ZNO. This is the difference peak oriented was observed along the HKL values. These are the HKL values of this XRD. Finally, the average crystalline size was found in the range of 8.9 nanometer in our XRD result. Then FTA in an optical properties, we have discussed two methods, FTAR and two studies, FTAR and UV. In an FTAR stands for Fourier transform infrared, and IR radiation is passes through the sample. Some of the radiation is observant and some is passes through the transmitted. In an FTAR spectrum is a molecular spectrum which is used to characterize for both organic and inorganic. This is the FTR spectrum. In the FTR spectrum, the transmitted on y-axis and the wave number can be seen on an x-axis, and also y-axis can also have an observant. Depending on, you can get a spectrum. Various peaks are presented. These are the various peaks presented. All the range in 575.9 is a ZNO stretching vibration, and 1005.3 centimeter inverse is a CN bond for primary amine and CO for alcohol. Then 1118, 1355 centimeter, 1383 is a primary and secondary alcohol. In 1595.8 centimeter is a aromatic nitro or alkali compound. In 2925 centimeter and 3435.8 centimeter area, stretching vibration of hydroxyl compound. This is the information can be provided by FTIR. It can be identify unknown material and also determine the quality of the sample and then determine the amount of the component in a mixture. This is the UV visible spectrum between the graph of observant and wavelength. In the observant spectra of the pure zinc oxide, it shows the high observant in the wavelength range of 240 nanometer. This is the graph for direct band gap energy of the pure ZNO nanoparticle. Its the band gap energy was found in the range of 4.67 electron volt. Then the final application of zinc oxide nanoparticle, it is used for the manufacturing of rubber and also other creams, ointment, and also treated to treat skin diseases. And the number of zinc oxide powder are used to ceramic industries and various paint to be coating agent, and then manufacturing of concrete and so on. Then conclusion in this study, we have synthesized the solvothermal method for pure ZNO nanoparticle successful, and its particle size have been reduced. The optical band gap energy values found to be 4.67 electron volt. These are the reference of my manuscript. Thank you.
Renuka Devi, well presented. Here you mentioned that the FTR is used for quality of sample. So this quality of sample is what?
Pure ZNO nanoparticle, ma'am.
Quality of sample is pure. ZNO particle is present. Okay, only ZNO particles are present here.
Yes, ma'am. I selected only for a pure ZNO nanoparticle.
You tried very dopant?
No, ma'am. Further, I will develop, ma'am.
Okay. Is there any question from audience?
No, ma'am.
Yes?
No question, ma'am.
No questions. Okay. Well, ma. Next.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank you, Mom. Let us move on the other presentations. Presentation number 6, L. Gugunathan. Welcome, sir.
Welcome, ma'am. Good morning, ma'am.
Good morning, Gugunathan.
But the screen is showing, ma'am. PPT.
Not visible.
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 It's visible. May I present, ma'am? Okay. Good afternoon to all. Screen move out. Okay. Hello.
Sir, we are hearing you.
Good afternoon to all. I am Goganathan, under the guidance of Dr. Venkatajalapati, Professor of Physics at Annamalai University. My present paper title is Fourier transform in infrared spectroscopy studies confirm the presence of plastic particle in the table salts. Introduction. The slide showing me. Hello.
Yes, sir.
It is visible, sir. In introduction slide.
Is it visible?
Yes,
Visible.
Okay, so introduction, plastics, synthetic organic polymers, 500 different compounds based on polymers with 13,000 grades and 25,000 trade names. Global production of plastic has increased from 1.5 million tons in 1950 to 299 million tons in 2013. Recent Science Journal paper by James Back et al. 2015 found that the amount of the mismanaged plastic waste generated by the coastal population of a single country range from 1.1 metric ton to 8.8 metric ton per year, which the top of 20 countries mismanaged plastic waste encompassed 83% of their total in 2010. The figure shows the global map of mass of mismanaged plastic waste generated in 2010. The top 20 countries of mismanaged plastic waste, the India plastic marine debris million metric ton, the value is 0.09 to 0.24. The plastic debris distribution in the world oceans, the recent oceanographic model output shows that 5.25 trillion particle weighing 268,940 tons floating in the world oceans and accumulated more in all 5 subtropical gyres. Erickson 2014. Environmental effect of macroplastics in oceans. This figure shows the macroplastic entangle of the coral reefs, sea animals, and the sea bridge. The next one is the sea fish and the turning species affected the macroplastics of plastics. Microplastics. The plastic particles in the size range 1 nanometer to less than 5 millimeter in diameter. It has two types, primary microplastics and secondary microplastics. Primary microplastics, plastics that are manufactured to be of a micro size are defined as primary microplastics used in toothpaste, facial cream cleaners, scrub, and in a medicine as a vector for drugs. Pellets are nuttle, plastic raw material for manufacture of plastic materials. Secondary microplastics. Secondary microplastics which are generated which are micro-sized plastics in the marine environment are physically wind, wave, and current, chemically in UV radiation, and biologically microbial activity, are degraded and fragmented into micro-sized less than 5 millimeter particles. Since last two decades, plastic waste are casted away in the oceans, rivers, and shorelines, and surface water is polluted. The most famous manufacturing method of ocean salt is by evaporating of the water in the ponds, wherein salt water is strenuously desiccated by the exposure to wind and daylight. Source and transfer of the microplastics in the marine environment. The land-based sources are rivers, wind, tourism, sewage, stormwater discharge, littering, industrial activities. Sea-based sources, commercial fishing, recreation boats, ship sewage deposit, offshore activities. This figure shows the land-based and sea-based plastic source wastes entering the oceans. And this is the International Pellet Watch the program. They're monitoring the plastic waste in the world oceans. The next one is tsunami indicated pellet debris 2011 Japan tsunami the images. Our Indian scenario until now very few research articles related to the microplastics research have been published in India. The first one, the Srinivasan Reddy 2006, and second one JST 2013, Third one also there JST, and fourth one also JST. Objective of the present study. The major point of the current study is focused on the plastic particle contamination in the table salts, which are available in the supermarkets throughout Chidambaram town and Tamil Nadu in India. The study area Chidambaram town, the map. This is a sample collection. 4 commercially different brand of famous table salts have in the South Indian supermarkets were collected throughout Chidambaram town, Tamil Nadu. These packets were of 1 kg. Hydrogen peroxide treatment. The sample glass container of the 1 liter were arranged in for each brand of salts, 250 gram of the salts from each. It's audible, no?
Yes, sir.
Oh, okay, sir. Now we are seeing to the hydrogen peroxide treatment. The sample glass container of the 1 liter were arranged for each brand of salts. 250 gram of the salt from the each packet was placed in them. 100 milliliter of 30% of hydrogen peroxide was added in all the container to assimilate the organic matter. They were enclosed and positioned in the magnetic stirrer with a cord plate 65 degrees Celsius at 80 RPM for 24 hours and then at room hotness for 48 hours. Material methods. The 800 milliliter of the distilled water was added in all the container and stirred with a glass stirrer until the table salts were fully dissolved. The table salt solution from all the 4 glass container using a vacuum system were transferred onto a piece of 11 micro 4-size Whatman paper. Then the Whatman filter paper were placed in the clean petri dishes with the covers and dried at room temperature for a plastic analysis. The first analysis, the FDR characterization of plastic particles. All over the world, microplastic contamination has been studied in the different ecological substances. The first one is salt, water, sediment, biota, and dust in air. The way of FDR method. And now I find out that this method of FDR, the FDR spectra were recorded from Department of Chemistry, Annamalai University, Tamil Nadu, India, using the instrument name in Agilent carry 630 FDR with a resolution of 4 cm inverse. The result and discussion of FDR studies. The first figure shows the FDR spectrum of A sample from Gujarat, and second figure 2B FDR spectrum of B sample in Gujarat. And the third one, figure 2C FDR spectrum C sample from Thoothukudi, and figure 2D FDR spectrum of the D sample in Thoothukudi. The figures 2A, 2B, 2C, and 2D shows the various type of plastic particles were identified in the table salts. Brands A, B from Gujarat, brand C and D Thoothukudi in Tamil Nadu. Above the graphs, I find out the FDR results. They are nylon, polypropylene, low density polyethylene terephthalate, high density polyethylene terephthalate, Teflon, and polystyrene, including the spectral range of the wave number listed in the table 1. And also the FDR spectra of the corresponding various wave number have been listed in table 1. This table 1 showing the chemical composition of the polymer types. First one is the plastic topological, second FDR spectral wave numbers, third corresponding wave numbers, fourth their assignments. The first one, the plastic topology nylon, that there is a spectral range given and the corresponding wave number also given. The assignment is C double bond O stretching vibration. The second one, polypropylene, and their wave number given here. The third one is low density polyethylene terephthalate, and the fourth one is high density polyethylene terephthalate. Finally, conclusion, the FDR results strongly suggested that the 4 brand of table salts from Gujarat and the Thoothukudi in India, which were commercially purchased from South Indian supermarket throughout Chidambaram town in Tamil Nadu, were contaminated by plastic particles. In my conclusion, I find out the table salt is contaminated by plastic particle. That's all, ma'am. Thank you. Thank you all. Thank you. It is audible?
Yes,
Hello,
yes,
sir?
it's audible.
Any questions? No.
Sir,
Yes,
I want
Then
to ask.
what is the main advantage for this your paper? No, what is the main advantage for that one? How to apply for the society or some application? Can you tell me?
Yes, sir. I tell now. Sir, regularly we are using the salt, our food, and multi-purposes. Our eating salt is contaminated into plastic particle, micro size and macro size, invisible nanoparticles also available. We are not find out. Just we confirmed our salt to FTR studies. Easily find out it is good or bad. If contamination of plastic particle is affecting to our human bodies,
Yeah.
this FTR studies, I easily find out the easy method. In further higher studies is available, SEM, EDAX, and more studies is available. But easily society people find out that the FTR method and confirm the easily whether salt contaminated plastic particles or not. Thank you, sir.
Then we can use that in future. Instead of plastic, we can use microplastic.
Where use?
Microplastic, no? In future,
yeah.
instead of plastic, we can use that because plastic is very dangerous one, no? That's why.
Yes.
Yes,
Sir. Sir, we are indirectly we are consuming plastics in regular life. We are using salt. The routinely we are using. Please, we are confirm our salt whether contaminated or not, and we are informed to the manufacturing factories.
Okay.
Then, sir.
Okay, thank you very much, Bhuganathan. Thank you, welcome.
Great pleasure, sir. Thank you, sir.
Sir, I have a doubt. Sir, what are the substances that present in plastic? Because of that reason, the microorganism even they can't decompose the plastic. What is the reason, and what is the substances present in it?
The number of substances present there, the number of polymers. Already I told us polyethylene terephthalate, low density polyethylene terephthalate, high density polyethylene terephthalate, polystyrene. A number of polymers are available. Just we are confirmed to studies. Our samples sent to another the FTR Raman, FTR studies. The preliminary studies is FTR study. We easily confirmed whether our food and any contamination, the functional group is available or not. This is a preliminary studies and easily find out our contamination of the salt in the plastic, whether or. Thank you, sir.
Sir, I want to ask a bit. I want a bit clarification about that. Sir, you said that there are many substances. So, is there any substances that that help the microorganism to decompose the plastic as earlier, as soon as possible? Because it takes millions of years to decompose.
Yeah. In future, the 2015, the compare than the oceans animals, compare than the plastics. The 2015, many plastic is higher than the ocean animals and plants because we avoid two plastics and recycle we using and avoid plastic. That is the main target of our aim.
Thank you so much.
Bhuganathan?
So tell me, ma'am. Thank you.
From your studies, what do you insist to the world?
In my study, we are prevent plastics because the plastic.
To avoid.
Avoid the
to
plastic.
avoid.
Yes, ma'am.
Oh.
But is the plastic? So tell me, ma'am.
So.
Ma'am, this plastic is indirectly we are routine
Yes,
life. The plastic is routinely we are unaware we are using daily, ma'am. But now is the emerging field. We are aware about the plastics.
Okay. If any.
Ma'am, voice is not audible, ma'am. Hello, ma'am. Hello, ma'am. Hello, sir. Audible, sir.
Yes, audible, please.
Next question, sir.
Sir, please mute your mic.
Okay, sir. Any other questions, audience?
No, sir.
So may I conclude, sir, my session?
Yes, okay.
Thank you, sir. Thank you, sir. Thank you. Great pleasure, sir. Thank you all.
Welcome. God bless you. Welcome. God bless you. Thank you. Thank you.
With this, today's presentation gets over. It was a great day. We shall meet on tomorrow on the second day of the conference. Take care, all of you. Bye.
Thank you. Thank you. God bless you. Have a nice
Thank you.
day. Thank you. Thank you.
Thank
God
you,
bless
sir.
you. God bless you. Thank you. Thank you.
Thank you. Thank you.